Let's begin by considering the scope of what we're confronting. I want you to reflect on this thoroughly because the majority of individuals don't truly grasp how immense these figures are. Our sun represents a fairly typical star, correct? Nothing exceptional about it. Within our galaxy, just one galaxy, there exist at minimum 100 billion stars. Some calculations suggest 200 billion. Now, for each of those stars, we've learned that possessing planets circling them is entirely typical. It's not uncommon whatsoever. Actually, most stars have planets orbiting them, and I emphasize most. We've identified over 6,000 confirmed exoplanets thus far, and that figure continues increasing monthly. Yet here's what genuinely stretches the imagination. Astronomers estimate, based on the information we possess, that there might be approximately around 1 trillion planets within our galaxy alone. 1 trillion, and each individual one represents a world. Each possesses a surface, a potential for chemical processes, for phenomena we might not even have conceived of yet. Now, you might be questioning, all right, so what? Numerous planets exist. What connection does that have to extraterrestrials? Well, we're not seeking planets harboring alien life. We're specifically searching for habitable planets, locations where, based on our current understanding, life could potentially survive. Researchers have this notion they designate the habitable zone. And I appreciate this expression because it's candid about what we're attempting. We're making assumptions. We're proposing if a planet sits at precisely the appropriate separation from its star, neither excessively hot nor excessively cold, then liquid water could exist on its surface. Now on Earth, based on everything we've observed, everywhere we've discovered liquid water, we've discovered life. Consequently, we're essentially gambling that liquid water serves as a reasonably reliable indicator. It's termed the Goldilocks zone, which I consider among the poorest labels in science because it's excessively charming for something this significant. However, all right, here's what they've computed. Based on data from missions like Kepler, astronomers have estimated that there could be somewhere between 40 and 180 billion planets in our galaxy that reside within the habitable zone of their stars. Allow me to restate that. At minimum 40 billion, that's not a transcription error. That represents 40 billion worlds where, according to our comprehension, life could potentially exist. So this is where the reasoning appears foolproof, correct? Trillions of planets, tens of billions positioned in habitable zones. The universe has existed for 13.8 billion years. Life appeared on Earth nearly as promptly as conditions permitted. The mathematics indicates life should be ubiquitous. Yet, and this represents the essential point, we have discovered absolutely nothing. No transmissions, no visits, no verified microbial remains in meteorites, nothing. This dilemma has become so renowned among researchers that they've even assigned it a designation. It's termed the Fermi paradox, named after the physicist Enrico Fermi, who supposedly inquired during lunch one day, "Where is everyone?" And that constitutes the enigma. That's the genuine enigma. Not whether extraterrestrials exist. Statistically, they probably do. The enigma is why we don't observe them. Why can't we locate them? Where are they? This represents what I intend by extraterrestrials are already present, yet we cannot perceive them. They're concealed by the immense distances of space and the constraints of our search methods. Allow me to discuss what we actually understand about the search thus far. Individuals occasionally become enthusiastic when they believe we've discovered proof of alien life. And I want to be straightforward with you regarding what qualifies as proof and what doesn't. The issue is we don't even possess a satisfactory definition of what life constitutes. I recognize that sounds peculiar, yet it's accurate. On Earth, we characterize life as something capable of replicating itself, something undergoing evolution, something maintaining itself and utilizing energy. Yet there exist hundreds of definitions, and every individual one derives from the sole life we're familiar with, ourselves. Carbon-based, DNA-utilizing, cellular life. But what if life elsewhere employs none of those elements? What if it's silicon-based? What if it employs some type of chemistry we've never conceived? Then all our definitions become meaningless. So when astronomers search for what they designate biosignatures, chemical indicators suggesting life, they're essentially making informed assumptions. They're stating, on Earth, this molecule is exclusively produced by living organisms. So if we discover it elsewhere, perhaps it indicates life. Yet here's the complication. Simply because something is exclusively produced by life on Earth doesn't establish it can exclusively be produced by life everywhere. Recently, considerable excitement emerged regarding a planet designated K2-18b. It's approximately 120 light-years distant within the habitable zone of its star. In 2023, utilizing the James Webb Space Telescope, researchers detected a chemical called dimethyl sulfide. On Earth, this molecule is produced exclusively by living organisms, mostly minute organisms in the ocean termed phytoplankton. Consequently, headlines proclaimed, "We discovered signs of alien life," and individuals became highly enthusiastic. However, and I want you to attend carefully, other researchers immediately cautioned, "Wait, because we've committed this error previously. In 1976, we dispatched Viking landers to Mars. The Viking missions included experiments designed to detect microbes in the Martian soil, and the outcomes appeared promising. One experiment seemed to indicate signs of living organisms in the soil. Researchers were enthusiastic. Yet then other experiments on the identical samples discovered no organic compounds, no indications of complex molecules you'd anticipate from life. And subsequently, researchers discovered that a mineral on Mars called perchlorate could generate the identical chemical reaction that led individuals to believe life existed. So it was probably merely chemistry, not biology. This has occurred previously, and it occurs repeatedly. We perceive what we hope to perceive. K218b serves as a good illustration. The signal for dimethyl sulfide was extremely faint. Disagreement exists regarding whether it's genuinely present, and even if it is, it might have been generated by chemical processes we don't yet comprehend. The concentration they detected would be extraordinarily elevated if it originated from life, which is intriguing. Yet intriguing doesn't equate to verified. Here's what I believe is essential to comprehend. Discovering life is challenging. Actually, allow me to phrase that differently. Verifying that something is genuinely life and not merely chemistry is genuinely difficult. We require multiple lines of proof. We require independent confirmation. We cannot simply discover one element and declare, "That's it, we found aliens." We need to examine again, contemplate alternative explanations, scrutinize our assumptions. So, where could life actually exist? We don't know. Yet let's consider the possibilities. Within our own solar system, several intriguing locations exist. Mars, for example. We understand now that Mars possessed liquid water on its surface billions of years ago. Water might still exist underground. If life ever originated there, it might have retreated underground to remain liquid. We've dispatched rovers to Mars searching for indications of ancient life, and the possibility is tantalizing. Yet again, we have discovered nothing. Jupiter's moon Europa is intriguing. Beneath a thick layer of ice, a liquid ocean might exist. That ocean could be warmed by tidal heating, the moon being compressed as it orbits Jupiter. Some of the most extreme environments on Earth, locations we considered impossible for life, turned out to be teeming with organisms. Researchers designate these organisms extremophiles. They inhabit boiling hot springs, in the deep ocean near volcanic vents, in rocks miles underground with no sunlight, no connection to the surface world. These organisms don't require sunlight. They don't require organic material from the surface. They simply require liquid water and some type of chemical energy source. This transformed everything regarding how we consider where life could exist. If life can survive beneath miles of ice in darkness with unusual chemistry, well then perhaps Europa's ocean isn't so impossible after all. Yet here's the aspect that concerns me. Even if we discovered microbial life in Europa's ocean or in the rocks beneath Mars, that would only provide us two examples of life in the universe, both within our own solar system, both near Earth, that's still not particularly numerous. And the universe is incomprehensibly vast. The distances involved in space are so immense that even the term immense doesn't adequately convey it. Allow me to attempt providing some context. Light from the nearest star to us other than the Sun requires 4.2 years to reach us. That's the duration light travels at the maximum possible speed. K218b is 124 light-years distant. That signifies the light we're receiving from that planet departed 124 years ago. When we direct a telescope toward it, we're not observing the present. We're examining the past, and we're receiving merely a minute quantity of light reflected from the planet's atmosphere. The James Webb Space Telescope, which represents our most advanced instrument for examining distant planets, needed to dedicate hundreds of hours. That's actual observation time on one of the most costly instruments we've constructed, merely to obtain a suggestion of a chemical signature from one planet. And even then, researchers disagree regarding whether the signal is genuine. Now consider what this signifies for the possibility of visiting or being visited. The nearest star is 4.2 light-years distant. With our present technology, a spacecraft would require tens of thousands of years to reach there. Even if extraterrestrials existed, even if they were advanced and intelligent and possessed superior technology to us, the distances are so immense that casual interstellar visiting doesn't appear feasible. You'd require generation ships. You'd require a motivation significant enough to dedicate centuries traveling through empty space. And even beyond that, if an alien civilization did exist and did possess technology to travel between stars, they still confront the issue of time. Civilizations emerge and decline, planets transform, technology deteriorates. Any civilization visiting Earth would need to accomplish it within a fairly restricted window where they possess the technology and we haven't yet destroyed ourselves or transformed radically. It's not impossible, yet it's not as straightforward as many individuals imagine it to be. So, this returns me to the original inquiry. Where are they? And I believe several potential responses exist. And I want to discuss what each signifies. One possibility, and this is actually what numerous researchers think might be accurate, is what they designate the Great Filter. The concept is this. Some extraordinarily challenging stage exists in the progression from non-life to advanced civilization. It's so challenging that it nearly never occurs. Perhaps it's progressing from chemistry to the initial living cell. Life did emerge on Earth, yet perhaps that was extraordinarily fortunate. Perhaps it occurs only once in trillions of planets. Or perhaps the filter occurs later. Perhaps life emerges fairly commonly. Yet progressing from simple microbes to intelligent beings is nearly impossible. Or perhaps it's the fact that intelligent civilizations consistently destroy themselves. Another possibility is what they designate the zoo hypothesis. This one's somewhat entertaining to consider. The concept is that alien civilizations do exist, yet they're deliberately not contacting us. Perhaps they regard us as being in a nature preserve. They observe us, yet don't interfere because they want to observe how we develop naturally. Or perhaps they've agreed to remain hidden from younger civilizations. It's somewhat science fictional, yet it's not logically impossible. Or there's another possibility I find intriguing. Perhaps intelligent life exists, yet we're simply searching in the wrong manner. We've been listening for radio transmissions. We've been searching for visible light. But what if extraterrestrials communicate using something we haven't even conceived? Or what if their technology is so advanced that what they employ appears as natural phenomena to us? Yet here's what I believe represents the most honest response. We don't know. We simply don't know. And that's acceptable. That's actually where optimal scientific inquiry commences. When you don't understand something, that's where the mystery resides. That's where the intriguing questions exist. What we do understand is that the sheer magnitude of the universe strongly indicates life should exist elsewhere. The chemistry that generates life, carbon, water, the fundamental components, that's everywhere. We've discovered organic molecules in meteorites. We've discovered them in the gas clouds between stars. We've discovered amino acids on asteroids. The chemistry of life appears inscribed into the universe itself. Yet we also understand that discovering life, verifying it beyond uncertainty, is considerably more challenging than individuals recognize, and we must exercise caution not to perceive what we desire to perceive. We must design our experiments carefully. We must obtain independent confirmation. We must consider what else could generate the identical signal. Here's what I believe is occurring. I believe the universe is probably teeming with simple microbes. I believe life probably emerges on a reasonable fraction of habitable planets, yet I believe intelligent technological civilizations are probably uncommon. I believe the Great Filter might be genuine, and perhaps we've already traversed it through fortune, or perhaps we're about to encounter it. I believe the distances in space are so immense that even if intelligence is common, actually encountering would be extraordinarily difficult. And then there's another possibility I haven't mentioned. Perhaps extraterrestrials are present, yet not in the manner individuals typically imagine. Not visiting in spacecraft, but perhaps as microbial life that arrived on meteorites. Perhaps as biochemical processes we don't identify as life. Perhaps as something we simply haven't conceived yet. Yet I believe the most essential point is this. The fact that we haven't discovered alien life yet doesn't constitute proof that it doesn't exist. It merely constitutes proof that either it doesn't exist or discovering it is considerably more difficult than we thought, or both. We need to continue searching. We need to dispatch more rovers to Mars. We need to examine Europa. We need to construct improved telescopes. We need to consider more carefully what we're searching for and how to identify it. And meanwhile, this puzzle, this beautiful, frustrating Fermi paradox, it maintains our thinking. It maintains our curiosity. It reminds us how much we don't understand. And I appreciate that. I appreciate mysteries. Mysteries are what scientific inquiry exists for. So, are extraterrestrials already present? Well, not in spacecraft stored in secret government facilities. I believe that's probably inaccurate. Yet if we're honest regarding the magnitude of the universe, they probably exist somewhere. We simply cannot perceive them yet. And perhaps that represents the most intriguing response of all, because it signifies we get to be the seekers. We get to observe the universe and attempt to comprehend it. We get to inquire, where is everyone? And we don't possess a satisfactory response yet. And I believe that's remarkable.